Okay, let's start to solve this question, max subsequence. So in that question, we have a max subsequence. What is that? Given a number n and a string s of size n, determine the maximum possible size of subsequence t derived from s such that no two adjacent characters in t are the same. You don't understand this question. So we have a string of size n, which you want to find as a t string, which are the subsequence of s. And what are the characteristic of t is that no two adjacent character in t are same. Did you get this question? So let me tell me about like what does it mean subsequence? Subsequence is a sequence that can be derived from another sequence by deleting some element without changing the order. So here we are not picking some element. Well, we are not picking some. We are deleting some element, and whatever the element left, that is called subsequence. Let's suppose we have apple, and if I delete this element, now whatever the element left, can we call? We can call this is a subsequence of apple. Yes or not? Did you get this point? Anyone who have doubt? What does it mean subsequence? If I delete this one, this is a subsequence of apple. But can you say that? Can you say that if apple is there, can I say that is LPP is a subsequence? Yes or no? Tell me. Is LPP a subsequence?
No.
No. Because why? We are not picking the LPP. We are actually have to delete some elements. If I delete this A and E, still we are not getting this LPP. So PPL is a subsequence, but LPP is not. So that is called the subsequence, and we really want to find the maximized size of subsequence. And the condition is like no two adjacent character in T itself. So one thing is very easy. Let's suppose A, B, A, B. It is a very greedy approach. You have to just pick the element. We have to pick this A, okay, and we can pick the B because this no adjacent element are equal. You can pick again A because it's not adjacent element. You can B again, okay, but you can't pick this B. Can you pick it? Can you pick it because it is a adjacent to B, na? So the greedy approach works here, and I'll tell you what this greedy is, how greedy works. So let's suppose this is in this total A, we can pick only one A. Yes or not? In this total A, can we pick only one? Na? Is yes or not?
Yes, sir.
Only A, only one A, and this C. So can we reframe this test case? Let's suppose I have A, C, D, E, B, E, F, G. So can you see that in that A only I can pick only one A. In that C I can only pick one C. In that D I will pick one D. In that E I will only pick one E. In that B I only pick one B. In E I will pick one E, F, and G. And that is the maximum subsequence that we can get through this. That is T. That is no adjacent element equal. Did you get this point? Yes or not?
Yes, sir.
Every element are picking and not two adjacent element are not picking. So that's why like we are deleting element. That's why I've even told like we are not picking in a subsequence. We are deleting. So we are deleting this A. We're deleting C. We're deleting this E. We're deleting this B. And this I'm getting the T. Now onto the subsequence. So let's try to code it. Okay. Let's try to code this. being as seen as. So let's suppose LL count equal to 1. Okay. Why I'm starting with 1? Because the first element must be distinct. Na? Okay. So that's why we're starting with count 1 and start with I index 1. We are not starting with index 0. Okay. Because the first element is definitely is one element and it is never be no, there's no adjacent. That's why we're counting 1. Now we are checking if S of I equal S of I minus 1. Think about it. If it is equal, what should I do? Let's suppose think about like if something like that a we have a count 1. Now if a this way a equal, what should I do? We should just we don't need to do anything, we just need to continue. Yeah? Yes or no? That is not whenever we are getting some encounter which has different characters from the previous one, then we have to count it. So I can do something like that. If it is not equal that like S of I is not equal to S of I minus 1, that means we are getting the different character and we really want to do character count plus plus. Yes or not?
Yes, sir.
Did you get this point till now? Let's suppose we are getting B here and C D. So the first character A itself is count equal to 1, I equal to 1. It will check this A is equal A, then we are not doing anything, we are moving A. Then you are checking A, I, this A is A equal to previous one, no. Is equal, then I move to I again. Again I'm getting the different character B, so count become 2. Then B is not the same, not different, then nothing has changed in count. Then CR we getting different, count become 3, then D become count become 4. The answer for this one is 4. Okay. So let's try to and that is analyze our macro. Okay. NL is this. So let's try to submit this. We just take the different character. Okay. We are not the concept is like the similar character which are very similar to togetherness. We have to pick only ones. Okay. That is the logic part. So our code become accepted here. So let's mark this question.